carefully centered on crosshairs in the eyepiece. Once that was done, the scales could be read in the X and Y directions, and a very precise position could be assigned to the star. From those numbers, it could be determined whether the star had appeared to change position.
Einstein has predicted that the warped space around the sun will create an optical illusion, making the stars appear to move outward ever so slightly.
Einstein predicted much less than a millimeter. This is not an easy measurement to make.
Unlike most theories that people put forth, Einstein's general relativity makes very specific predictions. Very tight, it's got to be this, and if it's not that, then the entire foundation of the idea has got to be discarded.
Extremely precise, painstaking measurements.
There was no wiggle room in Einstein's relativity because the idea that gravity is the manifestation of the curvature of space and time. You're going to say how much it curves and what happens to matter or light in the presence of that curvature? Calculate it, make the prediction? If the prediction doesn't come true, you don't go say, okay, let me see if I can tweak the theory. Not in this case.
You can see on these pages the kind of labor that Curtis had to endure in order to make these measurements. There's page after page after page of this. Some pages crossed out.
All you needed was one experiment to show that any aspect of relativity would fail. And he'd have to go back to the drawing board completely.
Curtis looks at the stars and sees nothing unusual.